Good day, everybody. My name is Busui Tulokbe Matthew. So I want to take you guys on some past questions of your physics. So this question we have here is actually question 3 and question 4 of our first test. Now 2019 set. So it's about temperature scales. Now the question states. Use the information to answer question 3 and question 4 sequentially. Now it says the resistance RT of the substance at temperature T degrees Celsius, which is measured by mercury thermometer, is RT. That means the resistance of the substance is given by this equation. That's R0, which is R0 over 1 plus AT squared, where R0 is the resistance of the substance at 0 degrees Celsius, and A being a constant is equal to 5 times 10 raised to the power minus 5 degrees Celsius minus raised to the power minus 2. Now from here we know this is a constant, since the resistance of the substance at 0 degree is always going to be a constant. It won't change since it's a constant substance that is inside the thermometer. So this R0 is always going to be the resistance at 0 degrees Celsius. Now that means, and now from here we can see that RT only depends on the temperature in which this mercury thermometer measures. And since this T being the only variable in this equation, from there we automatically know that in the question. Now the first question, that should be question 3. So calculate the resistance of the substance at 180 degrees Celsius as measured by the mercury in gas thermometer. Now the thing is to calculate what the resistance of the substance will be when a mercury in gas thermometer is measuring a temperature of 80 and 100 degrees Celsius. Now since this everything being dependent on this temperature, that means as the temperature of what the mercury in gas reads, the resistance of this will change by this relationship. So from here we automatically know R100 is given by this function. R0 1 plus AT squared. Now from here we automatically know what 1 is. 1 is given, A is given from the A. Now T is going to be what? T is going to be 100 since the temperature. Now some people do ask, are we meant to calculate this temperature like to an absolute value, which is the Kelvin value? Now the answer is no. Now we can see from all the questions we were given, from here the unit is in Celsius, this is also in Celsius. So why waste your time or thinking about what not and changing something to Kelvin? All you just need to push straight forward your answer and put it in Kelvin and put it in Celsius, since everything was given in Celsius. Now note we don't have R0, but from the options here, what we're given the option, we can see that everything that was given in the option is given in terms of R0, the temperature at 0 degrees Celsius of the substance. So therefore automatically know we don't need to know what R0 is before we get our answer. You get what I'm trying to say. So automatically all we just need to calculate is this. So it's still the same thing as 1 over 1 plus AT squared times R0. Since our final answer will still be in terms of R0. So we just need to calculate this. Now putting this into this equation, we have this 1 over 1 plus. Now from here A is equals to what? 5 times 10 raised to the power minus 5. Now T is equals to what? 100 degrees Celsius. So 100 squared. Now from here we punch this into our calculator. Now if you have a scientific calculator, it actually saves a lot of stress. You just need to punch everything, and just since the exam is OBJ, all you just need to do is just put it in your calculator and just put 1 plus 5 times 5 exponential minus 5 times 100 squared. Now this is it. So take the inverse of this. So this is, there's an R0. There's an R. Yeah, please do not forget that. So this is equals to 1 over 1.5 R0. Now take the inverse of this from here. The inverse is going to be equals to inverse of answer. That's going to be 0.667. So this equals to 0.667 R. Please, you can ignore my handwriting, it's not really clear, but just please help me manage it. Thank you. So please, you can just Now to calculate the resistance of the substance at 80 degrees Celsius. Sorry. So at 80, so you are looking for R80. So we do the same thing basically. So is equals to 1 over 1 plus 80 squared R60. 1 over 1 plus 5 times minus 5 times 80 squared R0. So let's do the same thing. Punch it into the calculator. Now basically this question is right, just inputting something in a formula and just solving it. So it's actually not that complex. It's just this actually the second question that is quite complex. So punching it in the calculator, we have 1 plus 5 exponential minus 5 times 80 squared. So this is it. So it's going to be equals to 1 over 1.32 R0. So taking the inverse of our answer, we have inverse of answer. We have 0.0757 R0. Now from here we have our answer. Oh, please remember that this is equals to R80. I remember that our R100 is equals to 0.667 R0. Right? So you have this. Now from our option we have this, that option A is given by R100 is equals to 0.667 of 660 R7. So these are our options. Now from here we can see that option A matches with our answer because R is 100 from our calculation was 0.667 R0 and R80 is given by 0.757 of R0. So automatically A is our answer. So going to question 2 now.